Okay, in this video we're going to look at how to differentiate Bessel functions. We're going to use these three formulas here. The first two are the differential identities, and the first one, the derivative of t to the new j nu, is t to the new j nu minus 1. The second one, derivative of t j nu over t to the new, is negative j nu plus 1 over t to the new. And then the third one we will use is this recurrence relation, which relates j nu plus 1 with j nu minus 1 and j nu. Okay, these have all been derived in previous videos, which you might want to check. All right, in these examples we are going to want to differentiate each of the given expressions, and then the final answer will express it in terms of j1 and j0. So for the first one, we have got the derivative of t to the power 4 j2 of t. Okay, so let's get on with this. So what's going to happen here, so we've got a derivative of t to the power 4 j2. What we will want to do is to rewrite this so that it takes one of these forms, either this form or this form, because those ones we can differentiate. So if you like, the exact derivatives in this context. So here we still got j2 here, so if that was t to the power 2, then that would be an exact derivative. So we are going to write this as t squared times t squared j2. Okay, henceforth we'll just write this as j2, but we know it's j2 of t. All right, then I can now use the product rule. This is going to be one term, this is going to be the other term, so treat this as one term. So if we differentiate t squared, that gives us 2t. Keep this fixed, and then now we're going to keep t squared fixed. The derivative of this, according to that formula number 1, is going to be t squared j1. We subtract 1 from the order of the Bessel function. And then after that, so this is 2t cubed j2 plus t to the power 4 j1. So the answer we need in terms of j0 and j1. So that means this second term is already fine, but this one we need to write it in terms of j1 and j0. And so using the third formula here, if nu is 1, this is going to be j2, this is going to be j0, this is going to be 2 over t j1. So we can make j2 the subject of the formula there. So when we do that, it's going to be 2t cubed into 2 over t j1 minus j0, then plus t to the power 4 j1. And then we can remove brackets now. This is going to be 4t squared j1 minus 2t cubed j0 plus t to the power 4 j1. Then if we collect terms, this is going to be 4t squared plus t to the power 4. That is all going to be times j1, and then minus 2t cubed J0. So that is going to be our final answer. Okay, and then in B we have got the derivative of J1 over x squared. So we have got the derivative of J1 of x all divided by x squared. We are going to do this one using two approaches. In the first one, we're going to use the rule or the identity involving the negative power, which is this one here. And then in the second case, we're going to use this one here. Okay, so in the first case, so notice in both cases the power needs to be the same as the index of the Bessel function. So in the first case, we're going to write this as 1 over x times J1 over x. And then by that second identity, we can differentiate that. So again, we're going to treat this as a product. So using the product rule, when we differentiate 1 over x squared, we get negative 1 over x squared. Then in the second term, we keep 1 over x fixed. We differentiate J1 over x. So we're going to have to add 1 to the index of J. So we're going to have J2. So this thing is going to give us negative J1 over x cubed minus J2 over x squared. Then we need to write J2 in terms of J0 and J1. So we're going to have negative J1 over x cubed minus 1 over x squared into, remember, J2 is 2 over x J1 minus J0. And so when we remove the brackets here, we're going to have negative J1 over x cubed minus 2J1 over x cubed plus J0 over x squared. So finally, this thing is going to be J0 over x squared minus 3J1 over x cubed. All right, so that is the method using the identity with a negative power. Now in the second approach, we're going to use the identity with the positive power. So here we have got J1 over x squared. So if we multiply both numerator and denominator by x, then because we are trying to have t to the new j new for that first one, so in this case new is 1, so we're going to have x j1, and then this is going to be times 1 over x cubed this time. Okay, and then we use of course the product rule. So derivative of this is going to be xj0 times 1 over x cubed. Then if we keep this fixed, so xj1 fixed, derivative of this is going to be negative 3 over x to the power 4. And then this answer is already in terms of J0 and J1. So simplifying, we simply have J0 over x squared minus 3J1 over x cubed, which is exactly the same as this answer we got here. But you're going to notice that this approach is shorter, because instead of increasing the index or the order of the Bessel function, it actually takes it down towards what we want as our final answer, because we want our final answer in terms of J0 and J1. So in the first one, because we're using that second identity, we first go to J2, and then we have got to express that in terms of J0 and J1. So that is why it takes a bit longer. Okay, so that we're going to keep in mind for future reference when we come across other expressions of a similar nature. Okay, then in part C, we have the derivative of t squared times J2 of 2 square root t. Okay. Now, in this case, the argument of the Bessel function is not t. So before we differentiate, we're going to have to use the chain rule to rewrite the whole expression, because we want this variable to be the same variable as what we have there. So we're going to let u be equal to 2 square root t, and then we're going to want to write everything in terms of u. So from here you can see that so square root t is going to be u over 2. So t is going to be u squared over 4. So that means t squared is going to be u to the power 4 over 16. Then the derivative dt is going to be du dt times du. Okay, du dt is going to be 1 over square root t. Okay, but square root t is u over 2, so this is going to be 2 over u du. Okay, we can now write this in terms of u. So let's call it f. So that means f is going to be 2 over u du. U squared is going to be u to the power 4 over 16. Then this is going to be J2 of u. This is okay now. The constants we can collect. So 2 over 16 is 1 over 8. So we're going to have 1 over 8 u du. Then, okay, let's just write u to the power 4 there. So what we're going to do in a similar manner to what we did in our first example, we're going to write this as u squared times u squared J2. Then this we can differentiate readily using number 1 at the top. So then using the product rule, derivative of this is going to be 2u, and derivative of this is going to be u squared J1. Okay, then if we remove the brackets, we're going to have u squared over 4 J2 plus u cubed over 8 J1. Then this we need to rewrite in terms of J1 and J0. I think we already know by now. That's going to be 2 over u J1 minus j naught, and then plus u cubed over 8 j1. Then if we remove the brackets, this is going to be u over 2 j1 minus u squared over 4 j naught plus u cubed over 8. That's u cubed over 8 here, j1. Then if we bring the j1 terms together, I have u2 over 2 plus u cubed over 8 j1 minus u squared over 4 j naught. Then from our substitution, u over 2 is just square root t, so we're going to have square root t there, and then this is just a cube of that, so it's going to be t square root t j1. Then u squared over 4 is just t. Okay, so then finally we can write this as square root t into 1 plus t j1 of 2 root t minus t into j naught of 2 root t. And so that is going to be our final answer. At this point, we're going to give you an opportunity to have a go at the last two. So if you want to pause the video and just have a go at D and E, and then when you continue the video, then you can compare with our answers. Alright, so we're now going to scroll down to our solution for D and E. Okay, so for D, we notice that the argument of the Bessel function is not t, so that means we employ the chain rule to rewrite this in terms of a new variable u, and so our derivative is going to look like this. And so if we write this as u squared j2 times u, then we can use the product rule, which gives us that. And then rewriting j2 in terms of j0 and j1 and collecting terms, we get 8u plus 4u squared j1 minus 4u, sorry, u cubed here, minus 4u squared j0. And then finally rewriting it in terms of t, that is the expression that we get. In E again, since this is not x, we introduce a new variable 1 over x, and so d dx becomes negative u squared d du. Rewrite the whole derivative. Here we could just differentiate this actually because it's j1 over u, and then write everything in terms of j0 and j1. We'll leave that as an exercise to you to show that you find exactly the same answer as we do here. We have multiplied both numerator and denominator by u, and then this is now our first term, that's our second term. Differentiate using the product rule, we get this, and then rewrite everything in terms of x. Alright, thanks for watching. Please do subscribe to support the channel, and yeah, you can post your comments at the bottom. Thank you.